As we are going to pray. Let's humble ourselves as we are going to pray. Mighty King of glory, we thank you for today. We thank you for each and every Father that you have enabled us to wake up. Father, we thank you that we have gathered and we are here to study. We call upon your Holy Spirit to come and guide us as we are going to study. Father, we call upon your knowledge and understanding so that we understand each and everything that is going to be taught. Through Jesus' name we have prayed and believed.
Amen.
Amen.
Okay, thank you so much, Linda, for the word of prayer. And good morning, everyone. Thank you so much for keeping time. Uh, yes. So we are going to start from where we ended last week, and we are going to start from the vector equation of the line. Before we left, we had started on the vector equation of a line, and we say that when we talk about a vector equation of a line, is given in this form that if I have any point is given by A, whereby A is any known point along the line, plus our parameter, which can be a lambda, and then we said times the direction. So that's what we say that we shall look at in case I have I want to obtain the equation of this vector, then it means that I must have a known point, which point we called A, and then we said that we must know the direction our vector is taking, and in order to get this point, which we called R, when this is our position vector, we said we shall get that known point, then times the lambda, then times the direction our vector is pointing in. Then we say that we have three different ways we can write our vector equation. We say that it can be written in a vector form, like R is equal to A plus the lambda D. Then we say that it can as well be written in a parametric format, whereby we say that under parametric format, we shall have x under the parametric format, we can have it as x minus A is equal to lambda D. Then we said we can as well have it in a form of the Cartesian equation, whereby you say that under Cartesian format, we shall have x minus A out of D is equal to lambda. So those were the different things we looked at. And today I remember by the time we went off, we are looking, I had given you this activity, and this is where we are going to start from. Now, when you look at the activity we have at the hand, they're asking us to find a vector and then the Cartesian equation of a line that passes through the point and is parallel to the line whose equation is this. And then from what we say that for in order for us to get this equation of a line, we shall always say that we must have a known point along that line. And when you look here, that known point is given by 2, -1, and 1. Then we say that the second thing, we must always have the direction for our vector. And we say that always this direction for direction of a vector is always parallel to a given line. Now, since they have given us a second equation, always what we have to do, as long as that equation that has been given to us is parallel, then it means that they are going in the same direction. Note that in case these are parallel vectors, it means that this is this is like the vector where they have given us this point of 2, -1, and 1. And there is another equation here for this particular line, which is parallel to this line. That means that these two lines, or these two lines are parallel. And being that are parallel, that means they will have the same direction. So in order for us to get the equation, the direction for this line they need, it means that we just need to extract the direction for this particular line. And we say that when we express it in a Cartesian form, these digits down are always your directions. That down here, these are the directions. So that means that our direction for this particular vector will be 2. I can write it in a vector format. We are going to come here and say that now our direction is going to be 2I plus the 7j, then minus the 3k. And sometimes, please, you need to take note that sometimes they may give you this Cartesian equation when it is not written in the order. So let me say they may say y plus 1 out of 7 is equal to z minus 2 out of negative 3 is equal to x minus 3 out of 2. Remember, when we are writing, we write I, j, and k. So always take note that x, the one that is down, is the one for I, y goes with the j, and then the k or the z goes with the k. So sometimes you need to look around and check out whether it has been given in that particular order. Now, in order for us to get our vector equation, we shall just say that our vector equation we are going to have is going to be r, allow me to use r, is going to be r is equal to our known point, which is 2, negative 1, 1, then plus our, here it is up to you. You can decide to use mu as our parameter, 2, 7, and negative 3. And this is our vector equation of a line. Members, are we on the same page with that? Or we are leaving someone behind? Is that fine to everyone? I'm waiting to see. Okay, paper saying yes. Very good. Okay. Yeah. So that's what we said. And now in order for us to get, because they asked for the vector equation, that's where you end. In case you want, please, there's no problem. You writing it in this format as 2I minus j plus k, and then you say plus mu into 2I plus 7j minus 3k. It is very, very fine. Now, the next format, we are going to write it in our Cartesian form. Now, we say that in order for us to write it in a Cartesian form, the first thing you do, you express this r in form of x, y, and z. So that means you can write it as, I think you can write it in form of x, y, and z equaling to 2, negative 1, 1 plus our mu into 2, 7, and negative 3. That is always your first step that you have to take. Okay. Yes, Martina.
Good morning, teacher.
Morning.
Yes, I'm noticing like the question has lambda and the like our response we're using mu. I don't know if we can switch or it's better to stick with lambda.
Okay. You stay on. You stay on. Now, when you look at this, we have two equations. This lambda was for the second equation that we had that they gave us. Then we are finding a new equation for another line that we didn't know. I don't know that you're getting it. That you have two
Yes,
lines. For this line, they gave you your parameter as lambda. But for this
mm,
line, they did not specify what your parameter is. So it is up to you to use any parameter of your choice.
but not lambda.
Yes, it may not be necessarily lambda. You can use any parameter of your choice.
Okay,
Okay.
thank you.
Can you take us from here now?
Using the Cartesian form.
Yes.
Okay. The Cartesian form will now say x, y, z, like in column form,
Mm-hmm.
is equal to, what's it? No, to be x
From
is
here,
equal to 2
x is equal
plus
to,
2 plus 2 mu,
okay.
then y is equal to negative 1.
Can I separate?
Yes, plus 7 mu. Then z is equal to 1 plus negative 3 mu.
Okay.
Then we'll bring the 2 on this other side to get x minus 2 is equal to 2 lambda. Then we'll divide both sides by the 2. To get here, mu is equal to x minus 2 divided by 2. Then the same thing for y. We'll bring 1 this side to get y plus 1 is equal to 7 mu. And then we divide both sides by 7 to get y plus 1 out of 7 is equal to mu. Then for z, we'll say z minus 1 is equal to negative 3 mu. We divide both sides by negative 3 to get z minus 1 divided by negative 3 is equal to mu. Then we'll equate all of them to mu. So we'll say x minus 2 divided by 2 is equal to y plus 1 divided by 7 is equal to z minus 1 divided by negative 3, all are equal to mu. Yes.
Okay, thank you. Yes, so members, this is how you were supposed to carry out your number, and I expect you to define, to say that let my mu be my parameter, and let the direction of the vector be represented by d, and maybe let r be any point along the line. Yes, so you define what you are using. Kindly let me know through the chat whether we are good now to start our work. Members, are we together? Can we now continue? Okay, not yet. Okay, let me give you some few minutes. Yes, so this is what we left behind last time. So now we are going to continue from here. Okay, now we are going to continue from here. Okay, now we are going to look at the concept whereby they have asked us to show whether a given point lies on the line. Now here they have given us a line, but they want us to know, they want us to show, does this point really lies on the line? Now, whenever they give you a point and they ask you to show whether that point lies along the line, in order for you to know whether that point lies on the line, you have to check out whether the parameter you have is consistent at whatever point you are obtaining. So we are going to find out whether that parameter of lambda is the same for all the given directions. So whenever they give you that show, always find out whether the lambda is consistent for the I, for the J, and for the K direction. So that is what you always have to do. Whenever they ask you whether this point lies along the vector line, whether it lies along the line, for you what you need to do is find out, does the parameter of lambda the same for all the given directions? So please, you can take note of that a vector lies on the line if the value of lambda is consistent for all the given directions. So what are we going to do? Now, when you look through the question, they have given us our R. So we can come here and say that now we have our R equals to 2I plus 3J plus 4K, then plus lambda into I minus 2J plus 4K. Now, where there is R, remember R is any point along that line. So, and here they have given us a point along the line. So we are going to substitute it in the position where there is R. So now we shall come and say 4I minus J plus 12K is equal to 2I plus 3J plus 4K, then plus lambda into I minus 2J plus 4 plus 4K. Now what are we going to do? We can first collect like terms and then equate the i's. So we can come here and say now, this is I and this is I. So members, hope you can agree with me that I can write this as 2 lambda plus I, then plus. Now the next one, I can deal with the j and the j. So when I'm dealing with the j now, I write 3 minus 2 lambda, then everything times j, then plus the last one, which is the k and the k, which is going to be 4 plus 4 lambda, then into k, and this side I'll have 4i minus j plus the 12k. Now, the moment I reach at this point, I'm going to equate the directions. I'm going to equate the I direction, the j direction, and the k direction. And then I find out, are they consistent? So what am I going to say? For I direction. So for the I direction, this side I have 4, this side I have 2 plus lambda. So I'll come and say 4 is equal to 2 plus lambda. So I find the value of lambda. So this will be 4 minus 2 is equal to lambda, and 2 is equal to lambda. So I'll find out for my lambda for 2. Then can I ask someone maybe to take us through the j, and then another one maybe through the k? Okay, yes, Linda, go on.
We shall say
Mhm.
-1 for
Okay, that
j,
is for j direction.
for
Okay.
yes,
Oh, Linda, continue. It seems I've lost Linda. Please.
So
we
for
have
let me
said
continue.
negative.
Okay, let me continue with that j. So
Okay.
it's -1 is equal to 2 plus lambda.
Negative G for J.
Yes, -1 is equal to 2 plus, no, sorry, 3 minus 2 lambda.
Okay.
So that will be -1 minus 3, which is -4,
Okay.
is equal to -2 lambda. When we divide through by -2, we shall have lambda is equal to 2.
Okay. Continue with the other one as well.
So for k, we shall have 12 equals to 4 plus 4 lambda, which will be 12 minus 4 equals to 4 lambda. That will be 8 equals to 4 lambda. We divide through by 4. We still get lambdas too.
Okay. Okay. Yes. Thank you, Dr. Peace. Yes. So members, now the moment you find out that the values of lambda are the same throughout, then you are going to make your conclusion. You're going to make your conclusion. Then you can say that since since lambda is equal to 2, or since the value of lambda is consistent for all the directions I, j, and k, therefore the point 4i minus j plus 12k lies on the line. Yes. And please, there is no harm if for you did your work in this format whereby you say that my R is 4, -1, and 12 is equal to 2, 3, 4, then plus lambda 1, -2, and then 4. If you approach it this way, it is as well very fine, whereby now here you say for I direction, I will say 4 is equal to 2 plus lambda. Yes, someone can approach it in this format. It is still very okay. Yeah, as long as you find. Should you find out that one of the values for lambda is not the same for any of the given direction, then that is an indicator that that point doesn't lie along the same line. Okay, I don't know. In case you have a question, let me say, Josephine, is it a question?
Yes, teacher.
Okay.
Good morning, sir.
Morning.
So, my question is, on this other method you were trying to do,
Mm.
why did I thought the R was equal to 2I plus 3J plus 4K? Why did you instead use the 4I negative 1 and then 12K? Because I
Remember,
thought you kept shooting the other formula.
hey,
The
remember
one
this
of
R, are you saying this R?
yes.
R is a point, is a point on at any like, let me say this is a line. This 2I plus 3J is this known point here. Then R can be a point here, can be a point here, can be a point here. Now the question has given us one point that they think is on the line. This is the point, and they want us to find out whether this point actually lies along this line. Are you getting it? Now this point R is the one they have given us to test. So this one is the one you place here in the position of R and then equate it. But for you to know whether it is lying there, then the value of lambda is the one that shows us whether it actually lies along the line. Are you getting it?
Teacher,
Not yet.
teacher, first wait. Which one did you
Mm.
say that you put in the position of R?
This point here, they want us to show 4I minus j plus 12k.
Oh, so here where they're saying that R is equal to this, they could perhaps use any other letter.
Here, where there is R,
Yeah.
yes, they can give us another point. Even if they had given us 3I minus 12j plus maybe k, this one will remain there. But this R can be any point for it keeps on varying, keeps on changing.
No, teacher, I don't know whether you're kind of trying to understand what I'm asking. Okay, I
Okay.
think the formula is R is equal to A plus lambda D, isn't it?
Or A plus lambda D, yes.
Yeah. So that being the case, I personally, I would
Mm,
say that in a
mm,
position of R, I'm going to
mm,
substitute in this vector that they give us in the question that R is equal to 2I plus 3J then plus 4K. That was what I
mm,
was going to substitute in. And then on the position of A, I would put
mm.
there 4, negative 1, and also 2K. And then on the one of D, I use this one with the lambda. I don't know whether
Oh,
that makes sense.
okay, now from when you look at this formula you have given us, are you seeing the formula? I want you to
Yes.
just compare the way it is. Or let me first let me say they have given you y is equal to 2x plus 1. Are you seeing this?
Yes,
When
teacher.
they ask you to show whether this point, let me say 1 or 1, 2, lies along this line, how do you prove it?
That still I would say
Mm-hmm.
uh one in a vector format. Sorry, in a column format, yeah.
Okay, now I'm
One,
taking you back
two,
to the equation of a line. I'm just asking, imagine they have given you y is equal to 2x plus 1. Are you seeing that? And they
yes.
ask you to show whether the point, let me be more specific, whether the point, this one, lies along the line. How do you prove it? Or how do you go about it?
Uh should I say first get the gradient over?
Okay. Now, for this one, what you do, remember this is your x, right?
Yes.
And this is your y.
Mm.
So in other words, they're asking you, when you substitute in the value of x here, do you get your value of y as 1? The moment you get so, it means that this point lies along the line. So that means you're going to come and say y is equal to 2 times 0 plus 1. And you get your y is equal to 1. And when you check here, you notice that your y is actually 1. So that is how you show that a point lies along a line. Now, whenever they ask you to show whether something lies along the line, it is just a matter of you substituting from the equation that has already been given to you. You get that point and you substitute it there in that equation.
Yes.
I don't know that it is clear now, Josephine.
Yes, thank you, sir.
Okay. Okay. Any other person or we are good to go? Okay. Okay. Let me hope we are good now to continue. Yes, Matthew.
Teacher,
Yes.
morning.
Morning.
Teacher, from I'm lost on the second step.
Which step?
This one of 4i minus j plus 12k equals 2 into,
This one.
yeah, that one.
Now, are you seeing this I here?
Mm.
When you open the brackets here, this lambda multiplies the I, so you get lambda I. This lambda multiplies this, you get minus 2 lambda j. This lambda
Mm.
multiplies here, you get 4 lambda k. Are you seeing that?
Yes.
And here there is a plus. Now here, this I and this one here, since they are in the same direction, you combine them. So you say 2i plus lambda I. But this side here, our lambda is 4i. But this I here, I can factorize it out since it's the same. So I get 2 plus lambda, everything times I.
Yes.
So that's how it comes about.
Okay, thank you, sir.
Okay. Okay. So members, this is just the summary. Whenever they ask you to prove that any point, substitute the point into the vector and confirm whether there is consistency in the parameter. Okay, I have this one. Yeah. Read through. And now I want to tell you, like I told you earlier, please take note that your parameter can be any letter. It's not necessary that it is going to be lambda, not that it will be mu, not that it will be maybe gamma, or no. It can be any letter. It can be even T, it can be H, it can be any. So for you, do not get used. The moment, as long as you notice that your equation that has been given is in this form, OA, then plus lambda, then times the direction. As long as it is in that format, then just know that is the equation of the line. For the parameter, can change to anything. Okay, now I have this one. I want you to read through. And I'm going to ask you now for each and everyone to first try it out. They have given us the vector equation, they have given us the installation point, and the engineer is asking whether the monitoring sensor lies along the pipeline. So can we first try it on our own? So I'm taking an assumption that everyone now is trying, but we can have a volunteer as others are finalizing to be taking us through what you are doing. Yes, Ruth.
Good morning.
Morning.
Yes, so we start by highlighting our not Cartesian, but our equation of the line. R is equal to 2i plus j minus k into brackets plus t into 3i minus 2j plus k. Then we substitute our point, suggested point, which is 8.
Which format are you using? Column or this horizontal format?
Let's use column.
Okay.
8, negative 3, 4. Then on this other side, we have 2 plus 3t.
Okay.
And then we have 1 minus 2t. Then negative 1 plus t.
Okay. Okay. Allow me this is okay, but I know someone may ask us, can I first put that step off?
In ijk.
Yeah, because
Okay.
someone may ask us where we have obtained it. Okay. Okay, first give it to us in that format.
That's it's equal to
Mm-hmm.
2 plus 3t.
Okay, this one here.
Oh, sorry.
Okay. We can continue now.
Okay, now we have
Mm-hmm.
2 plus 3t. Then 1 minus 2t. Then negative 1 plus t. Yes, so then we equate the x, y, and z. So 2 plus 3t is equal to 8.
Okay.
Equal to 8, that is 3t is equal to 6, and then t being equal to 2.
Mm.
Then for j, 1 minus 2t is equal to negative 3. Negative 2t is equal to negative 4. And then t is equal to 2. Then for k, it is negative 1 plus t is equal to 4. And t being equal to 5.
Okay. Okay.
So
Continue.
therefore,
Mm-hmm.
since the value of t is not the same for I, j, and k, so the point does not lie on the planned pipeline route.
Okay. Good. Yeah. Can you include the word the monitoring
Monitoring,
sensor?
yeah, I saw it. Okay,
Uh-huh.
so since the value gotten after solving, since the value of the monitoring sensor is not the same for I, j, and k, therefore the monitoring sensor does not lie on the planned pipeline route.
Okay. Thank you. Yes. So members, hope it is okay to everyone. Thank you, Ruth. According to the chat, Ken said doesn't lie. Martina says, okay, they don't lie. Martina, check out that last point. Chiza, okay. Okay, they are not consistent. Okay, doesn't lie. Yes, better now. Okay. Members, are we good to continue? Is that okay to everyone? Doesn't lie, doesn't lie. Okay, good. So we are going to continue. And always do not forget to respond back to the item. Okay, I have another one here. So read through. Okay, Trish says we are good to go. Okay, now let me ask everyone to first do part A. Feel free to write for us your answer in the chat, and then we'll go to part B. So everyone is doing part A at the moment. It is the same question, members. Yeah, it's the same question. I've just put it in this format. Okay. Feel free to share with us your answer in the chat, what we have obtained. But someone can as well raise up the hand and you tell us what you have come up with. Oh, sorry. I wanted part A. Part A. Oh, the vector equation, that's the first thing. Has everyone been able to come up with a vector equation? Oh, we are still writing the item. Okay, people are writing the item finished. Okay. In case you finish, feel free to go to next part, part B. Yeah. Someone to give us the vector equation you have come up with for part A. Okay, Melissa.
Morning.
Morning.
the vector equation I've come up with is R. No, since we have been given R as 6s, I'm going to use another value for R. Is it okay?
It is very fine.
So T
Okay.
is equal to 1
Vertically or horizontally?
column
Column.
1 -2 3 plus lambda 4 -1 2.
Okay. Thank you. That is correct, Melissa. Let me hope that is the equation everyone has. Okay, now we go to the second part. I want us also to first try out the second part on our own. To see whether we can be able to get that value of R and the value of S. So let's first try on our own. Now here you need to remember, if these points are to lie along the same line, what could be the condition? Since now you have already the vector equation, can we try? Mm, Finished. Okay, according to Ruth, she's getting -31 and -16. Okay, Ruth, check out. More so the -13. Sorry, the -16. Okay, Dr. Peace. Yeah. As we give time for others to finish, maybe Dr. Peace you can take, or another person. Okay, Ruth has made a correction. Another person who wants to take us through. Okay, yes, Gilbert.
Yes, good morning, sir.
Morning.
Mm, For us, for us to get the values of R and S, we know that the points, like for the point to lie in to be in the same line, when we calculate for the value of lambda, in all cases, that is I, J, and K, it must be the same. And since we have the value of J, we can use that one. But let's first state the formula. So continuing from there, and until we put R6S, then we equate it to 1, -2, 3, plus 4, negative 1, 2. So since we find that we can use the 6, you can use the 6 under for the direction of j to find the value of lambda. So we say for direction of j direction, we say 6 equals negative 2 minus lambda. So if you bring the 2 this side, it becomes 8 equals to negative lambda. And since we are finding lambda, lambda will be equal to negative 8.
Okay.
So now we can substitute in the value of lambda to get the values of r and s. So r will be equaling to 1 plus negative, it is negative 8 times 4, which can, yes, times 4. Then it's 1 plus negative, or minus, oh sorry, plus, you can say plus negative, or you can just say minus 1 minus 32. So our r is negative 31. So s will equal to 3 plus negative 8 times 2, which is 3 minus 16, giving us negative 13. So the value of r is negative 31 and the value of s is negative 13.
Okay, thank you, Gilbert. Members, let me hope we agree and everyone is fine with that. Okay, from the chat, Martina is okay, Jan is okay, Justus is okay, Ruth is okay, and Peace. Okay, and I think everyone is okay. Anyone with a question on this before we continue? Or we are good to continue? Okay, I think members are very fine. Yes. And now the last part, they just wanted us to check whether uh, okay. Yes, Justus.
Good morning, sir.
Hmm. Morning.
Like I was having an inquiry.
Hmm. Yes, please.
That after you making the brackets like step 2,
Hmm.
isn't it possible for you to carry this other bracket that is on the equation of t, then you take it this side and you leave the lambda constant alone?
It is very fine. Like you carrying the bracket saying R6S minus 1 negative 2 3 equals to lambda 4 negative 1 2.
Yes.
Yeah, it is very okay. It's very okay.
Okay. Okay,
Yeah.
thank you, sir.
Okay. Then someone, I think someone was asking, could it be okay to give a reason? It is very fine. It is very fine. So you say that here, one of your introductory statements, you can say that for the values of R and S to lie along the same inspection line, the lambda should be consistent or is the same. So that's why you consider it the same. Yeah. Then for part B, they just wanted you to state whether the proposed point is correctly positioned. Here you can, since they just wanted you to state, you could just say that since for the point to lie along the same, the line, the lambda is the same, and since lambda is the same, therefore the point is correctly positioned. Yeah, here there is no need for you to make the calculation because when you look at it, you note that the lambda you used to find the value of R and S and the 6 was the same. Therefore, it means that the point will lie along the line. So that means the point is correctly positioned. Okay. Are we going to continue? Okay. I think we are going to continue. This one, just take a screenshot. You'll try it in your free time. This one, you'll try it in your free time. Okay, I'm going to take an assumption that now everyone has been able to, has finished to take a screenshot. Okay, now we are going to look at the angle between two lines. Now, when we are finding the angle between any two lines, take an example. We have a line R, which is maybe OA plus lambda D1. And I have another line. Let me say this is R1, and I have another line R2, which is maybe OB plus maybe mu D2. Now, if I want to find out what is the angle between these two lines, always what I have to do is that I'll have to just get the direction vectors of these two lines. I'll extract this direction vector, I extract this direction vector, assuming that D1 is maybe I'm going to just say x1, y2 and x1, y1 and z1. And for this direction, D2 is maybe x2, y2 and z2. Members, through the chat, can you tell me, how do you think we are going to get the angle between those two vectors? Hey, I want you now to recall, when we are finding the angle between the two vectors, which concept do we apply? Hey, through the chat, you can say, maybe this is what I think we are going to do to find it. There is a concept we looked at. How do we find the angle between two vectors? How do we find the angle between two? Okay. Ruth has said dot product, we dot the directions. Very good. The dot, yes. So whenever we have two vectors and we want to find the angle, we are going to dot the two directions. So in order for us to find the angle, we shall get the directions and then we dot them. Do not forget from definition that in order for us to get the dot product, I'll say D1 dot D2 will equal to magnitude of D1, magnitude of D2, then times the cosine of the angle between the two vectors. And don't confuse them with what? With the scalar, or don't confuse it with the cross product. So the dot product helps us to get the angle between the two vectors. So I think we are good to start. Okay, that is our first item we are going to look at. So when you look through this item, they have told us that the vector equation of the line L1 is given by this. The part A, the line L2 is parallel to line L1. We say that the moment the two lines are parallel, it means that the directions for those two vectors are the same. And passes through the point A, write down the vector equation of the line. Can everyone first write that one down? You have a point along the line L2 and they have given us the direction. Can we first write it down, everyone? Mm. Mm. Yeah. Now you need to know. Yes. So feel free always to first define. You can say that for the direction, because you need to know the direction. So for direction of L2, which we can call D, is given by I minus 8J plus 5K. Because it is parallel to this vector line here, so then the known point, which they called A, then you say that my known point OA is 0i plus 2j plus 5k. But there's no need for you to write 0j, so you can just write it as 2i plus the 5k. Then that means that your vector equation for the line, you can still say R. Now, when you look at the one they gave us at first was in this format, so always also it is better you write it in that format. So I'll say that it's going to be 2i plus the 5k. Do not forget always write in this format OA plus. Now here it is up to you. You can use mu or you can use the lambda, you can use t. So it depends on what you want. It depends on what you want. But since they have already used lambda and mu, I can decide to use t, and then I'll put here times the direction. So I say plus t, then I put my direction I minus 8j plus 5k. And then I stop at that point. Then when it comes to part B, they have told us that find the angle between line L1 and this line here. Now, when you look very well, you notice that we need to find out for L1 what is the direction. Those who don't remember or those who have just joined, what accompanies the lambda or the parameter is always our direction. So our direction for line L1 is given by I minus 8j plus 5k. Then when you look at the second line that they have given us here, you notice that our direction D2 is 5i minus j plus 2k. And let me hope I'm not breaking. It has started to rain where I am. So hope it will not affect you. So what does it mean? Now it means that now we are going to go on and obtain the dot product because we said find the angle between these two lines. We only need to dot the directions. So we are working on this part. So we are going to say that D1 dot D2 should give us the magnitude of D1, magnitude of D2, then the cosine of theta. So I'm going to have my D1 and then I'll have my. So here I'll extract and say this is 1, -8 and 5. I dot it with the D2, which is 5, -1 and 2 is equal to D1. And we say that for D1 to get its magnitude, we said we shall have here our x squared plus y squared plus z squared. So I'm going to ask now each and everyone to first compute. Before we continue. Can we first try and see whether we can be able to get the angle? When you get the angle, feel free to share with us. Yes, feel free to share with us. I'm going to stop somewhere here and I first allow you to get that. So let's first be getting them. Let's be getting them. Let everyone be getting. So I'm allowing you to first continue from that point. Doctor, please.
Teacher, I had a concern on part
You are
A.
saying
I had a concern on part A, like the
on
response
part
to part.
A?
Yes,
Okay, yes, please.
you had written the equation of the line 2.
Yes.
You had written 2I plus
2I
5K.
instead of
Yeah,
J.
yes.
So please, this was I.
Yes, instead of J.
Oh, okay. Sorry about that. Yes. Hope members can see that it was J. Okay. Okay. My screen went off. My screen went off. But let me
Okay,
hope
sir.
members are getting the angle. Okay. From the chat, I'm seeing members have started getting 63.7, which is very correct. Okay, good, good. So I'm going to continue here. When we multiply these two vectors, we shall have 5 plus 8 plus 10. And this one will end up giving us 23. So here I expect members to have 23 is equal to root of 90, root of 30, cos of theta. So remember from your mathematics of sets, you can combine these two and say 90 times 30, and then you say cos of theta is equal to 23. At this point, it is okay for you to say 23 divided by the 90 times the 30 gives us the 2700 is equal to cos of theta. And at this point, you say theta is equal to cos inverse of 23 out of 2700. So your answer will end up giving you from the chart 63.73 degrees. And therefore you say that the angle between the line L1 and the line R is 63.7 degrees. Yeah. How do we get 23? Chiza 23 is from here when you get the dot product of D1 times D2. So here, remember, when you are multiplying the two directions, you'll say 1 times 5 plus negative 8 times negative 1, then plus 5 times 2. So 1 times 5 is 5, negative 8 times 1 is 8, and 5 times 2 is equal to 10. So when you add up 5 plus 8 plus 10, you get 23. Hope Chisa, that is fine. Okay. Anyone that is lost? Anyone that is lost, or we are on the same page? Are we on the same page, or we have someone that needs some support? If we are on the same page, kindly let me know whether we can continue. Are we good to continue? Same page? Same page? Okay, people are saying yes. Okay. So we are going to same page. Okay. So we are going to continue with another item. Okay. May I ask you now to read through this second item? Yes. And the first thing I'm going to ask each one of you, whenever you are given two lines, it is always better take them in the format you understand best. First take them in that format you understand best. And the best format can be this format here. So I'm going to first ask each one of you to rewrite this parametric form, back into this format here, such that we can make a good composition. So can we first write it in that format? Rewrite it in that format, everyone. Take it back from here into a format of that nature. We shall have one person to tell us how you have been able to take it. Before we reach part A and part B, we need also to first take it in that format. Okay. Anyone who wants to take us through how we have turned this parametric equation back into this format of the vector equation? Okay. Yes, Linda.
When we look at that equation, that line that they have given us, we see that x is equal to mu plus 4, then y is equal to mu minus 7, then z is equal to 3 mu. But from our formula, r is equal to a, the position vector of a,
Okay.
plus lambda d.
Okay.
When r is in the format of x, y, and z.
R is in the format of X, Y, and Z.
Then what we see here, for example, here they have given us mu, not lambda. So there in the equation that I've given, we can put there mu. Now our position vector of A, we are going to take them as 4.
Okay.
-7, then 0
Okay.
plus mu. Then our direction vectors, we have 1, 1, and 3.
Okay.
Then
Okay.
we can
Perfect.
take them back to the
Uh-huh.
IJK
So in
format.
RG, we can write it as
We have 4 plus mu I,
okay.
yeah, like that, then plus mu 1,
Uh-huh.
that is I, j, then plus 3 k.
Okay. Thank you, Linda. Yes, so this is how
Okay.
I expect your thing to be. Now, when you look at first part A, they asked us that to show whether L1 and L2 are not parallel. Now, you need to remember that under what circumstances are lines parallel? Now, the lines are parallel, or in order for you to check for what you call parallelism, one, those two lines to be parallel if the direction vectors are scalar multiples of each other. So what do you need to do? You are going to extract the directions for the two lines. If you find out that the scalar product, that one is a scalar product of the other, then those two lines are parallel. So we look at the directions of those lines. If they are a scalar product of each other, then you know that they are parallel. So I can say that let D1 be the direction of L1, and then D2 be the direction of L2. So extract D1, its direction, we have it as 1, 1, 3. Then when you look at D2 you notice that its direction, I think uh, I'm going to interchange a bit. L1, I think this is our L1, which I'm calling L1 is here. So its direction instead is 6, 1, 3. And D2, its direction is 1, 1, 3. Now you need to use your math. You ask that for any two lines to be parallel, or for anything to be parallel, or for them not to be parallel, then we should not have any value whereby is a scalar multiple of each other. So members, you can say that for the lines not to be parallel, for L1 and L2 not to be parallel, then D1 should not equal to a scalar multiple of D2. That's what you are going to prove. So I want you to check out when I pick a point this side, allow me not to use K because K may confuse with the directions. So can we use M? Let me use M. So you can say that maybe when I use for I, when you use for the I direction, for D1, you have 6. Here you have 1. So you note that 6 is equal to your M, then times 1. So you notice that here M is equal to 6. Then when you J for your J, you notice that 1 is going to equal to M. Then when you go for the K direction, you notice here you have 3 is equal to 3M. So here your M is equal to 1. But you notice that the values of M are different. Here you have 6 and here you have 1. And therefore it means that that one proves that they are not parallel. And then here you're going to say that since the scalar M is not consistent for all the directions I, J, and K, therefore lines L1 and L2 are not parallel. So that's how you prove. Therefore, you are going to say that therefore, or since the value of M, or since the scalar M is not consistent for all the directions I, J, and K, therefore D1 is not equal to M D2. Therefore, lines L1 and L2 are not parallel. I don't know whether members we have obtained that. Are we together on that? Okay, Gilbert says yes. Okay, Martina says yes. Okay, okay. Yeah. May I ask you now to continue on part B and everyone will get the angle? And don't forget always to make that good conclusion. Don't forget to make your conclusion. You respond back. Now I'm asking you now to do for me part B. Let everyone now get the angle. Okay, Justus, Matthew, Hans. Okay. Let's now go on and get the angle between L1 and our line L2. I'm not getting, is it peace? Maybe you can ask. Oh, I don't know whether this person is surely able to hear, but I'm going to ask someone who's using a phone. Maybe if you know to take a screenshot, you can help our sister here. Her microphone. Okay. Okay. She has enabled it. You may ask.
Master.
Yes.
Yes. Good morning, sir.
Morning. Were you
Morning.
hearing us?
Were you hearing us? Yes, I was.
Okay.
But I want you to pardon me on the last example you made for L1 and L2 not to be parallel, because I'm having some failures in connections here.
Okay. We are
Okay.
saying
We
that
are saying that
for lines to
for
be
lines to
parallel.
be parallel. Yes.
Okay, for the lines to be parallel, always you check out the direction. That if these two, if I have line, this is L1, and I have this as my L2. For these two lines to be parallel, there must be a value which when you multiply, you get exactly the other. Take an example. When I have, let me say, my direction as 1, 1, and 2, and I have another line which is 2, 2, 4. When I look at this line L1, this is this direction and this one, I can note that these two are parallel. Why? Because there is a value which when you multiply, you get exactly the other. Take an example. You can note that L2 is equal to L1. That when you multiply 2 times L1, you get exactly L2. And that's what we call parallelism. In other words, when you try to equate when you say L1 is equal to ML2, you notice that when I equate 1 here, I'll have M times 2. Your M is equal to a half. When you equate the I direction, you also notice M is equal to a half. When you equate the K direction, you also notice M is equal to a half. And now since the values of M are consistent through all the different directions, therefore it proves that line L1 and L2, their directions are parallel. But now for you to prove that they are not parallel, the moment you equate the directions and you find out that the corresponding values for the I, J, and K notation, the value of the scalar you are getting are different, then it means that they are not parallel. So that's the thing you check out. Like how we checked out, extract the direction of the first line, extract the direction of the second line, and then check out whether they are parallel whether the value you get for m for the scalar is consistent. If we had obtained 1, 1 throughout, we would have said that they are parallel. But since they are different, then it means they are not parallel. Hope it is clear now. Okay. I think I'm going to agree with everyone that our angle is 44.6. I agree on that. I agree on that. So in case that's not what you are getting, kindly you are going to check out where the problem is, but I'm going to maybe just summarize it here such that members can now check out whether actually, because we said you set D1, D2 is equal to magnitude of D1, D2, and then the cosine of theta. Then you come with your direction 613.113 is equal to magnitude, and here magnitude I know you are going to get, this is what, 4, 6 squared 36 plus 9 plus 1, which is 46. Here 9, 10, 11, and then the cos of theta. So when you take the dot product here, you get 16 is equal to magnitude of 46, magnitude of 11, cos of theta. So your theta will be cos inverse of 16 out of 46, 11. And therefore, according to what people are getting, will be 44.7 degrees, I think. Okay, 44.6 degrees, which we can approximate 44.7 degrees. Yeah, Martina, that's okay. That's okay. Dravi, Kenny, Joanne, Justus, Gilbert. Okay, Olive, Hans, Samuel, Rachel, Peace. Conclusion. Therefore, the angle between the line L1 and L2 is 44.7 degrees. Sometimes do not get confused. They may ask you, what is the acute angle? In case, even if you find the word acute, you need now to remember that the word acute means angles between 0 and 90 degrees. So in other words, they expect that the angle you are going to obtain is going to be within that given range. So that one should not confuse you. Okay, members, are we good to continue? Are we good to go? Okay, okay, yeah. Okay, good to go. For this one, I'm going to just write. For this one, allow me to just write, and I give you. Find the angle between the lines. Find the angle between the lines. Okay, which lines do I have? These are my lines. And now, like I told you, you need always to know how to extract, find the angle between the lines. So I have and okay. Yeah. And I'm going to ask you, everyone, I want first approve that the directions you have are correct. So I'll ask you to put for me in the chat the direction. This one I'm going to call it our line L1, and this one I'll call it our line L2. You put for me your direction for D1 and D2, the directions you are going to use before we continue. I'm looking through the chat whether people have the right directions. Most so. D1, 2, 1, negative 1. Yes, now I'm not saying we are not yet safe. We are not yet safe for the second direction, members. Remember what I told you earlier on? I told you that this value of x can never be a negative. That's what I was checking out, that this value of x can never be a negative. Always, you must have x minus y minus or plus, plus or minus, z plus minus, but you can never have x as your negative. So members, can we first make this to be better? Hope members now have seen it. Yes now. Peace, that is okay now. Members, first make this one out to be better. Yes, Joe. Yeah. I got you there. So first make it better. Now people are writing. Yes, Linda. Those who have seen where the thing was, yes. I don't know how you pronounce your name, but that one, is it peace? Yes. Yes. But PSY, that is correct. So members, don't forget, always check it out. Check it out such that you do not make the error. So I expect you to first come and say, how can this one be written in a good way? So I expect you to have said negative into x minus 1 out of 2, which now will give you x minus 1 out of negative 2 equals to y minus 3 out of 1 equals to z minus out of 2. Okay, good. Yeah, now members, we are good. And those who are not here, always what you have in the denominator is what forms your direction. So your D1 here can be 2i plus j minus k. Then your D2 is going to be negative 2i plus j plus 2k. Yeah. So members, proceed and we get our angle. Proceed and we get our angle. Okay. Melissa has got that. Melissa, can we check? Melissa, can we check? Something is not adding up a bit. So Melissa, first check and we see. Josephine as well, check. Seems something is not adding up a bit. I'm seeing people getting different angles. We are not safe. I'm saying everyone is getting a different angle. Okay, I'm saying Dr. Peace with something also different. Joanne, something different. Alia, something different. So who is okay? Who is not okay? Who's taking us through? Now, I think we need someone to take us through and we see where the issue is. Okay. Hey. Or can I make it more specific, members? Hey. 132 is okay. 132 is okay. But can I make can I put something here and maybe I make it a bit more clear? I don't know whether I should put it or not. Yeah. Some questions, in fact, allow me to just put here another word such that at least now also you get to know that sometimes they may specify. Can you add the word find the acute angle between the lines? And please make a conclusion now. Those who are getting 132, can you go on and find the acute angle as well? Okay. Melissa, unmute and take us through.
We are dotting d1
Mm-hmm.
dot d2
Mm-hmm.
is equals to magnitude of d1
Mm-hmm.
magnitude of d2 cos theta.
Okay.
So d1 is 2,
Mm-hmm.
1, negative 1 times 2, no, negative 2,
Mm-hmm.
1, negative 2. So
Mm-hmm.
2 times negative 2 plus 1 times 1 plus negative 1 times 2 negative 5.
Okay.
And then the magnitude of d1 is 6.
Okay.
I mean root 6.
6, eh? Okay.
Yeah, root 6. Then the magnitude of d2 is 3.
3. How did you get 3?
Let me see. This is 4
Mm-hmm.
plus 1
Mm-hmm.
plus 4.
Mm-hmm.
Sorry. That is root 9.
Uh-huh. Which is?
3.
Okay.
So this is negative 5 divide by 3 root 6 is equal to cos theta. So theta is equal to negative, yeah, if we compute to get that 132.9.
132 point?
9.
Okay. Okay, now we find the acute angle.
Do we get 180 minus that answer?
Perfect.
Then you get 47.12.
We get
47.12.
47.12.
2.
Okay, okay, okay. Yeah. So let me hope members that one is clear. 132.9 is very okay. When they ask for acute angle, then okay. I think now it is okay. Okay, that is okay. Members, are we on the same page on that? Yes. Hmm. So, okay, the same page, the same page. Yeah, now, which one is more safe? Now, even if they had not put the word acute angle. Now, even if they had not put the word acute angle, when you are stating the angle between two lines that intersect, often when we are stating it, we state it as an acute angle. Yeah. So you can first obtain, remember 130, or in case they have not put the word, put the angle you have obtained and then state it as an acute angle. Or you can write this and then write this afterwards. But then, in case the question is very specific, take an example. If for this one they had asked us, find the obtuse angle between the lines. Now, in case it is the word obtuse, then it means that the answer, you leave it as 132 because we know that obtuse angles lie between 90 and 180. Hope that is okay. Yes, hope that is very okay to everyone. Yeah, even if they have not told you that find the, unless they have stated it that find the obtuse angle, but you'll find that whatever, many of the textbooks you read, they always state your final answer as an acute angle. So whenever you find that you have got an obtuse angle, state your answer as an acute angle, unless when they have told you that they want it as an obtuse. But first obtain your obtuse and then say 180 minus. Because let me hope you know that like the angle we have obtained is the angle between 90 and 180. So now when we are stating it, state it between 0 and 90. Okay, I think that is very, very okay. I can give you, can I give you one more? One more? Okay, okay. Yeah, for this one, sorry. For this one, you're going to just state for me the direction. That's the only thing I am interested in to check whether people can be able to obtain the what? The direction for this. I have here, I have x minus 1 out of 3 is equal to y plus 1 out of 2 is equal to z minus 2 out of 1. This is equal to lambda. And I have another line, y minus 1 equaling to x minus 5 equals to z out of 2 is equal to mu. So members, I want you, this one is my direction 1, this is my direction 2. Yeah. Can I improve a bit? Let me put here 3. I've just improved it a bit. Just here, I want you to just help me state the directions. That's the only thing I want. So let everyone state which directions would you have used. I'm waiting. I'm waiting for the directions. Okay. Okay. I'm seeing the answers. Me, I'm going to first reserve my comment now. Mm. Someone is lost. Yeah. Oh. So far, I've not yet seen. Ah, uh, let me not comment. People will get will get what I am looking for. But if you have discovered where the trick is, kindly raise up your hand and you show us, mainly for D2. Because so far in the chat, I've only seen two people with the correct answer. Let me start with Josephine. Yes, Josephine.
Good morning, sir.
Morning.
I think
Hmm.
our D2
Hmm.
on the I, we
Hmm.
shall have 3.
Uh-huh. On
On
I,
the we
we
shall
shall
have
have
3.
uh-huh.
On the J, we shall have 0. And
Mm-hmm.
then on the K, we shall have 2.
Okay. Joseph, that's Josephine. Josephine, I have a question for you.
Yes,
Why do you say it is 0 for J?
because
Hmm.
like I, J, and K is the same as X, Y, and Z. And
Uh-huh.
since 1 minus 1 has no, what should I say, denominator, something like that.
Hmm.
So we assume, and you had said previously, that for the direction vectors, their denominator, those figures on the denominator, that is what we
Hmm.
consider to be the direction vector. And given
Hmm.
that y minus 1 has no denominator, so then automatically it means there is a 0 there. That is why I'm saying it would be 0j.
So you are saying here down there is a 0.
Yeah, that's what I think.
Okay. Now, Josephine, first tell us, what is 2 out of 0?
2 out of 0. Let me see a moment. That is what?
It is
Math error.
math
Math
error.
error.
So now, if it is math error, would this thing make sense?
No,
Can you think again?
it is 1.
It is 1. Why?
Because any number divided by 1 is that number.
So can you give us now the right thing?
So the right thing would be 3i plus
Mm-hmm.
j plus 2k.
Very good. Perfect. What other thing did you notice in the arrangement?
You confused us.
Okay, so what were we supposed to start with?
It was supposed to be x minus 5 over 3
Uh-huh.
is equal to y minus 1, which is equal to z out of 2 equals to mu.
Okay, very good. Yeah, so members, always arrange it in that form X, Y, and Z. Even if you find sometimes they're not going to put this like how she has been able to discover it. So for you, don't think that there is out of 0 because anything out of 0 does not exist. That's why on your calculators, you'll get a math error. So don't confuse 2 out of 0 to confuse it with 0 out of 2. Here you get 0. Here you cannot get anything. So never confuse those two. But also now because now she has stated something, let me ask you again in the chat to state for me what is the known point for this. For A, what is the known point? Let us call it position vector OA. And for this second line, let me call it position vector OB. Can you tell me what is your vector position, the position vector of OA? Can we extract it directly from here? And what is the position vector of OB? Extract it directly from here. Because now next time they may give you this line and they want you to use it against something and you fail to extract the position vectors. Can we also extract the position vectors and tell me what are those known points? Let me hope members have obtained what Josephine has told us. Eh, so yeah, Martina, that was okay. I saw peace also was okay. Samuel, we are not safe. Ken, we are not safe. Okay, from Alvan. Alvan, she is telling us 1, -1, 2. Good. Lydian, we are not safe. Lydian, we are not safe. Kenny, we are safe. Kenny, we are safe. Joan, we are safe for OA. For B, do not forget always the direction that we start with X, Y, and Z. X, Y, and Z. Always. Peace. Doctor, we are safe. So do not forget the order. The order matters a lot. Linda, we are safe. Justus, we okay now. Gilbert, we okay. Members, don't forget, you just extract here. 1, in case it is positive, that means it was negative. Negative, it was positive. So you just extract 1, -1, 2. Here, I expect you to start with the X first. So you say 5, 1, and here there is an hidden 0. So some of you may not see it there. So that is 5, 1, and 0. Okay, that's what I wanted you to notice because we are going to be applying it in some of the numbers we shall find. Okay, good. Now let me remind you. Now, please always take note. Whenever you dot any two vectors, I've dotted A dot B. In case you find the value you are getting is greater than 0, that's just know that the angle you are going to obtain is going to be an acute angle. So in other words, your angle is going to be between 0 and 90. In case you dot two vectors, like you have finished to dot and you have got your answer as a positive above 0, it is unacute. Should you get your A dot B equals to 0, this is what you say that those two vectors are going to be perpendicular. In other words, the angle you get will be 90 degrees. If you dot A dot B and you get your answer less than 0, it means that the answer you're going to get is going to be an obtuse angle. So in other words, your angle will be between 90 and 108. So the moment you notice that you are getting A dot B and you are getting an answer that is less than 0, in other words, you are getting negative, like for the previous number we had, then you just know that I'm going to obtain an obtuse angle, and therefore I'll have to write my answer 180 minus the obtuse angle to get the acute angle. So always take note of that. Okay, now I give you another one. Also, I'm going to write it. It says, given two lines whose equations are y equals 2 c1 plus mx1 and y equals to m2x plus c2 respectively, show that part A, I'm going to first put A, their vector equations are R equals to O C1 plus lambda 1m1 and R equals to OC2 plus mu into 1m2. Yeah, respectively. Yes. Let me first give you some few minutes to see whether it comes out. In case it comes out, you let me know in the chat that now it has come out. So let everyone first think. Yeah, everyone is thinking to see how we can obtain. Come back to that. So check out and see that we can be able to obtain that vector equation. In case it comes out, you let us know that things have come out. Okay, things coming out, or I give you a jump start. Do you need a hint? Okay, let me give you a hint, a small hint. In 2 dimensions, you may not be able to see the direction very quickly. Now, what you do, can we first write this one? Let me say this first equation. When you look at it, you notice that it is in the equation of our thing. Here, it means that your parameter is m. So allow me to use m1 here. Sorry, here I had to use m1. So when you, sorry. Okay. So when you look at this, you note what you do. First write this in a Cartesian format. I've given you the first hint. First write it. Oh, let me wait, members here also have noticed something I did not write well. Write it in the Cartesian format. So this is m1x. Can you first write this in the Cartesian format? First try. We have y equals to C1 plus M1x. Write it in a Cartesian format. But in the Cartesian format, I don't expect you to now write x, y, z. Remember here, you have already your y, you have already your x. Let me give you a jump start again. So here, when you take it to another step, you notice that I can write this as y minus C1 is equal to M1x, which I can go further and write as y minus C1 out of M1 is equal to x. Now, this is already in the Cartesian format. Now, to make it even much beautiful, I can write it as y minus C1 out of M1 is equal to x minus 0 out of 1. And therefore, since we say that always better we start with x, I can write it as x minus 0 out of 1 is equal to y minus C1 out of M1. Now, do not forget, members, that in a two-dimension xy, I told you that the gradient is the one that shows you the direction. Don't forget that the gradient determines whether it's going to be going down, up, or straight. So now this is your Cartesian format. Members, let me know through the chat whether that one is okay. What if I use the parametric format? It is okay, as long as Nancy, you are getting there. Members, is that fine to everyone? Okay, somehow. Now here we are dealing with the two dimension y and x. Why don't we use x down? Remember down, when Melissa, we are writing the Cartesian form, down, we are trying to find out what the direction is. So remember, in directions, in your equation format is given by y is equal to mx plus c. M is the one that shows you the behavior of a line, meaning that it's like the direction. It shows you the behavior of the line. Always your gradient determines, is it sloping? Is it going up? Is it straight? Is it vertically? I don't know that Melissa, that is okay. So that's why we are putting it down. We are bringing the gradient down. Okay, good. Can you now also do the same to the second line? Do the same to the second line. And someone will raise up the hand and you should tell us what is your Cartesian equation. In case you have a question, feel free to raise your hand such that we can help you before we build this number further. In case you feel there's something you need more clarification on, raise up your hand and then we support you. But also those who have been able to get the second one, kindly can raise up the hand and you tell us what you have come up with. Okay, yes. Let me see. Yes, okay. Let me first take on Samuel. Linda, keep your hand up as well. Okay, I want to take on Samuel. Yes, Samuel?
According to me,
Mm,
I was using actually from the line y equal to m2x plus c.
okay.
Then after writing y equal to m2x plus c, then I said I made the c to cross the equal signs.
Okay.
To y minus c2
Mm-hmm.
equal to m2x.
Okay.
Then I made x the subject by dividing through by m2.
Okay.
Then after that, I wrote it in a better way by saying that that may be also be written as y minus c2 over m2
Mm-hmm.
equaling to x minus 0 over 1.
Okay.
Then I can organize it in a very good way, and I say this is x minus 0 out of 1
Okay.
equaling to y minus c2 out of m2.
M2. Thank you. Thank you. So here, members, when you critically look at how this equation was, you can equate this to lambda. Then this one, you can equate to mu. Okay. Where is Linda? Linda, your hand was up. Linda, unmute. Thank you, Samuel.
Yes, sir.
Yes, Linda, now, from here, take us from here. What is your direction and what is your point?
For lambda,
Mm,
for that first equation, my direction is C1.
Direction. Remember? Okay, give us what is the known point.
The known point is Y.
Is Y. Is Y. Do you remember the known points? You read them from here.
Sorry.
Uh-huh.
The known point, we have 0
Uh-huh.
and C1.
C1. Good. And the direction?
We have 1
Uh-huh.
and M1.
And M1. Good. Can we now write it in a vector form?
Our array equals to 0, C1 plus lambda 1, M1.
Okay, now we go to the second one here. What is our point and what is our
The
known point?
points, the known points, we have 0 and C2.
Okay.
Then the direction vector, we have 1 and M2.
And M2. Good.
Then in the vector format, our array is equal to 0, C2 plus mu 1, M2.
M2. Okay, thank you. Yeah, so members, that's what they wanted for part A. You're going to allow me to clean off here a bit, making an assumption that people are already there, and I write part B. I write part B. So part B is telling us that here we are going to help ourselves on part B. The angle theta between them is So I'm going to have the first person to take us through, and then when she gets stuck somewhere in case, then M1 minus M2 out of 1 plus M1, M2. So the first person is going to take us through, then we shall help each other in case of anything. So you can unmute. So I'm going to be labbing a bit here. I'm going to be cleaning this part here. So who wants to? Yes, okay. Martina, we can start with you.
Teacher, so we're supposed to use like, can we use it as like, let's say, tan inverse, open brackets, m minus 1,
Okay,
m.
now this is what we are proving, Martina. So we must move from this side and show whether our answer corresponds to what they have.
Yes, like I wanted to say, like, now the formula I've given us here, tan inverse, open bracket, m1, m2 out of 1 plus m1, m2, is like our left-hand side, then our right-hand side. Can it be the stuff of D, like that, what we're doing to get the angles? Like,
Okay, first take us through. How do we find the angle between two lines? How do we find it?
we say D1, if we have like
Good.
D1 dot D2 is equal to
Uh-huh.
magnitude of D1, magnitude of D2, cos theta.
Okay,
So I
okay.
wanted
Now,
us to equate it to this. like the tan
Okay.
inverse 2. Yeah.
So what is our D1?
Our one is I think it's this one with mu up.
Okay, let this be our first line, and this is our second line.
Our D would be mu and then mu M1.
Okay, can we read on only the directions? Remember, D stands for the direction. So for the line
Oh yeah,
D,
sorry. There's one and then M1.
M1. What is our D2?
Our D2 is 1 M2.
M2. Okay. Hope members that is okay. Now we go to the first part. So here we are going to first calculate bits. So can you take us through D1.D2?
We get 1 plus M1 M2.
Okay.
Yeah, when you say 1 times 1, you get 1. Then when you do M1 times M2, you get M1 M2. Yeah.
Okay. Okay. Now we go to the second part. You are going to give us this one.
So for the magnitude, there's square root 1 squared plus M1 squared, where we get square root 1 plus M1 squared.
Okay. We go to D2.
It's the same thing, but 1 plus M2 squared.
M2 squared. Members, let me hope you are following up because we have to reach there. And now here, one thing now you need to take note is there are some topics that are going to come in here. Much as we are in vectors, but there is some knowledge you need to come up with. So can we substitute? What shall we have?
We have 1 plus M1 M2 is equal to square root 1 plus M1 squared, square root 1 plus M2 squared, cos theta.
Okay. Can we combine those square roots?
Yes, we can. So it will be 1 plus M1 squared is equal to a big square root, then open brackets 1 plus M1 squared, then open brackets again 1 plus M1 squared cos theta.
Okay, like that, right?
Yes.
Okay. Now, how can we remove this square root?
I think we can square both sides.
Okay. So allow me to show members here. So to remove the square root, we are going to square both sides. I square this side, I square this side. So that means we shall have 1 plus m1, m2, everything squared. What do we remain with this side?
1 plus M1 squared
Uh-huh.
plus 1 plus M2 squared cos theta squared.
Okay,
No,
which is the
cos
same as
squared theta.
cos squared theta. But do not forget that this cos squared theta multiplies everything, right?
Yes.
Okay, okay. Hope that is okay to the members. Are we going to continue? Now, always, as you proceed, I want you always to have the mathematical eye. You are going to ask yourself one question. The first question you are going to ask yourself is, when you look at here, where we are heading, we have something of tan. Then you need to ask yourself, how will I be able to bring in the tan? How does that tan come in? That is the question you need to keep asking yourself. Now, you need to ask yourself, if I'm to formulate a tan, how is cos squared theta related to tan. How can I bring the tan? We can help each other. Martina, in case you remember, it is okay. Or anyone who remembers, how can we bring in the tan? But the
Okay,
first,
I don't know if this identity would work,
mm-hmm,
but there is an identity that says tan squared theta is equal
mm-hmm.
to sine squared theta out of cos squared theta.
So you have said tan squared theta is equal to
Sine
sine
squared theta.
squared theta out of cos of squared theta.
Yes.
Now, when you check out, you can note that here we have cos, but now you are going to bring in the idea of sine, of which we may find it hard to get how sine is going to be related to tan. But let me first give you a jump start. Can you take cos squared theta the other side? And tell us what you get. I want us to remove cos squared theta and we first take this side. What shall we have?
So like by taking it manually or maybe, okay, by
Dividing
dividing or
it.
by, it would
Yes.
be 1 plus m1 m2 squared everything divide by cos 2 theta, yeah, is equal to 1 plus m1 squared, two brackets, then 1 plus m2 squared, two
Okay,
brackets.
good. Now, members, we are thinking from here. I want us to bring in the idea. One, you notice that I have 1 out of cos squared theta. What is 1 out of cos squared theta related to?
Ja, it's sec squared theta.
Good. Thank you, members in the chat. Sec squared theta, right? So here I can write 1 plus m1, m2, everything squared, then sec squared theta equaling to 1 plus m1 squared into 1 plus m2, everything squared. Very good. And now we bring in the idea. How is sec related to tan? How is sec related to tan? There is an
1
idea.
plus 1 plus tan squared theta is equal to sec squared theta.
Is equal to sec squared theta. Now, members, where there is sec, we are going to place that one. So I'm going to come here and let's say 1 plus m1, m2 squared into 1 plus tan squared theta will equal to 1 plus m1 squared into 1 plus m2, everything squared. I don't know, members, I want to clean the board as you write, but I'm going to clean here. I want to clean here. I want to clean this part here, and then I write up there. Now, our task is to make sure that tan remains on its own side alone, nothing with it. So what are we going to do? We are going to open up the brackets. Open for us those brackets, and you will see what we have. What shall we have for the left-hand side?
Shall I want for 1 plus m1 m2 squared? That's the
Now
side.
that one we are going to first leave it, but I want us to multiply it with the 1 plus tan squared theta.
So I can say 1 plus m1 m2 squared, then plus tan squared theta, open brackets, 1 plus m1 m2 squared.
Okay, that is correct. But I don't know whether other members in the chat we are moving together. But let me first check out. Members in the chat, kindly let me know whether we are on the same group. We are on the same page. Gilbert says together. Yes. From that step, same page. Okay. Okay. Melissa. Let me first pick Melissa to tell us. Melissa, which step?
That exact step. I'm not getting how you've opened that bracket. That
Melissa, are you
one.
seeing this part?
Mm.
So when I open, are you seeing this one? Multiply is the
Yes.
whole bracket, right?
Mm.
So you get this.
Mm.
Now, this tan squared theta also multiplies the whole bracket. You get this.
Oh, okay, I've understood.
Okay, okay. Then that is okay. Now, members, here we are going to do now the math. So, can we first take this one, the other side? What shall we have? Hope members agree with me that we shall have 1 plus m1 m2 everything squared equaling to 1 plus m1 2 squared 1 plus m2 squared minus 1 plus m1 m2 squared. Okay, I don't know whether our teacher went off, but hope that is okay to everyone. Now, can you open the brackets again? Open the brackets on the left and you tell us what we have.
Okay, we'll have 1 in brackets
Oh, okay.
1 plus m2 squared plus m1 squared, open brackets 1 plus m2 squared.
Okay.
Then you can put like other brackets minus 1 plus m1, m2. Okay, I can also open these ones, but I don't know. Yeah, to
Okay.
make it like that.
Okay. We open.
Then we'll have 1 plus m1, m2 squared plus m1 squared plus m1 squared, m2 squared. Let me see if there are any common. There are two m2 squareds.
Can you first open for us here?
Oh, there. We'll have 1 into brackets m1
Can we jump
plus.
that? Okay. Okay. It's okay.
Okay. Yeah. Plus m1, m2, 1 plus m1, m2 squared. No, that's not squared. Then we'll have 1 m1 plus, no, m1, m2. Then plus m1, m2 plus m1, m2 squared.
Okay.
Yeah. Then when we come back here, we see that we have two m2 squareds.
So members, I think they are going to allow us to cancel directly because I'm saying I don't want to remove this one, but maybe let me write it somewhere up here such that we can know what we are supposed to get. So this is tan inverse m1 minus m2 out of 1 plus m1 m2. Okay, I can now remove it. Okay, we continue.
I'm seeing that the ones can cancel.
Okay. Hope members can see the 1 and the 1 here can cancel.
Then
Okay.
I don't know if like okay, let me just leave that one. The m1, m2 squared can also cancel.
Also those ones can cancel. I've seen also. So we are removing the ones. We are removing these ones as well.
Yes.
Okay.
So we remain with m2 squared plus m1 squared, then minus 2m1 m2.
Minus 2m1 m2 equals to
Tan squared theta 1 plus m1 m2 squared.
Now, I want someone with a mathematical eye to tell us what is the whole of this, or someone who has seen it, or you have seen it, Martina. What is the whole of this in a compressed format?
M1 minus M2 squared.
It is M1.
I think M1 minus M2 squared, like everything squared.
Members, do you agree with that? Hope members agree that that is. Thank you, Alvan. Alvan. Okay. So this one is equal to
Tan squared theta 1 plus M1 M2 squared.
okay.
So to make tan the subject, I think we can divide both sides by 1 plus M1 M2 squared.
Okay.
Okay, so I see it coming, but then I don't know how to like remove the squared, so it's like, and how the inverse comes. So yeah, there I
Okay.
remove that.
In case I have this, how do we get x?
We do square root.
Okay. Apply the same knowledge.
Okay, we put square root on both sides. So to become tan theta is equal to M1 minus M2, 1 plus M1, M2.
Okay. Members, do not forget here, someone could have done like this. M1 minus M2 out of 1 plus M1, M2, everything squared. Because this 2 is the same. Okay.
And then we make theta the subject, so it will be tan inverse, open brackets, M1 minus M2 out of 1 plus M1, M2. Yeah.
Okay. Thank you, Martina. So, members, that's how you had to prove this. Yeah, but you have noticed that there is a concept you have brought in from trigonometry, meaning that many of these topics, you're going to find them integrated in other topics. Yeah. Yes, thank you, Alvan. We just compare. Okay, root, square root, Africa. Okay. Let me hope, I know some of you, we may have gotten a bit lost somewhere, somehow, but at least you have picked the idea and the different concepts you need to know. Hope we are together. I want to just give you some few numbers you're going to try out in your free time about today's concepts. Can I display the numbers? Yeah, people saying, yeah, I can display. But feel free now after the session, you also go through as an individual and see whether things can come out. So you can take a screenshot of this. Okay. I'm going to hope people have finished and also take a screenshot of this. Okay. Okay. So we shall start from here tomorrow. Sorry. Yeah, we shall start from here tomorrow, but we shall meet in the afternoon for other lessons. But maybe you can reach out to your friends. I know some of your friends do not have